This video will cover Chapter 1 entitled Exploring the Network. I highly encourage you to read through the curriculum in the chapter, as this video is only meant to be a brief introduction and overview as to what the chapter covers. One of the main goals of this chapter is to get us to think about how networks impact our daily lives and how we kind of take them for granted. Currently, we're in the Internet of Things, or the age of devices, as is described in this PowerPoint. We have all these different things and all these different devices currently that are connected to the internet. Our cell phones, our gaming consoles, our PCs, our laptops, our PDAs, all these different things are connected to the internet so we can have access to whatever we need. As we transition and as the internet grows, they talk about transitioning to the Internet of Everything. Where not only are we connecting devices, but now we're connecting people and processes and data and all these different things so that they can collaborate with each other. You can see here that they estimate by the year 2020 that we'll have 50 billion things, as they call them, connected to the internet, all collaborating and interfacing with one another, compared to about the 10 billion or so that we have now. Networks impact our daily lives, whether we realize it or not. A lot of times we just take these networks for granted. They support the way that we learn. Just think about how you're taking this class. You're watching this video online. No longer do you have to be on campus to take a class. You can do it all remotely, all online. The curriculum, the course shell, all of that has changed the way how education works. Networks support the way that we communicate. I always hear that, oh, your generation is horrible at communicating. It's not so much that we're horrible at communicating, it's just that we do it differently. Yes, our formal communication skills may lack a little bit, but we just communicate differently now. We do things like Snapchat and texting and posting on someone's wall on Facebook. We're still communicating back and forth. It may not be quite as personal, but it has changed the way that we communicate with one another. Networks support the way that we work. Flipping back to this slide here, we have people that are telecommuting or taking part in a meeting from miles away. They're using video conferencing and teleconferencing. No longer do you have to have that physical office space for an employee. They support the way that we play. Think about all the things you do for entertainment. Streaming video from Netflix, hopping on your Xbox or your PlayStation to play against somebody across the world in an online shooting game or an online sports game. You know, it used to be that our gaming consoles and things didn't have internet connections, but now that they do, it'd probably be hard to imagine a game without that online capabilities. So again, networks really do impact our daily lives. As I said, sometimes we just take them for granted, but if we really sit back and think, almost everything we do nowadays is impacted by technology or the internet or some type of network, whether we realize it or not. When we talk about networks, they're going to come in many different sizes. Small networks typically are going to be in our homes. We have maybe a few computers, an internet connection, maybe a printer, and they're all connected together. The point of a network is being able to share and collaborate amongst devices and people. That's why we connect computers to a network, so that we can share back and forth. We have small office, home office, or SOHO, sometimes they're called. A little bit larger scale, a few more computers, a few more users. In this class we'll talk a little bit about SOHO and get into the medium and large networks like, say, BSC's campus here. Hundreds of users, hundreds of computers. We'll talk about worldwide networks like the internet and wide area networks connecting multiple LANs together. So when you think about networks, don't just think of, just your home network or just the campus's network. There's all these different sizes and all these different things that come into play. I said one of the reasons that we want a network is so that we can share resources or collaborate amongst one another. There's different ways in which we can provide resources on the network, and the most common way probably is the client-server model. Many computers and many devices now can act as a client or a server. What a server does is it provides a service on the network. Like an email server will provide email to end devices on the network. Or a web server will provide web pages on the network. Our file server will provide files and folders that people can access on the network. So typically we have the servers, which are providing a service or a function on our network, and we have our clients, which are accessing. So if I have a web server, I'm going to use a web browser from the client to connect that. If I have an email server, I'm going to use an email client like Outlook or Hotmail to connect to that email server. Another type of way that we can provide resources on the network is a peer-to-peer network. A peer-to-peer network can have several advantages over a client server. Some of the advantages are it's easy to set up. I don't have to have that dedicated server hardware. I don't have to have a box with redundant hard drives and multiple processors and multiple network cards like we normally see in a server with a server operating system like Windows Server 2012 or Linux Red Hat or something like that. I don't have to have that dedicated hardware. I can just take two computers, put them on a network, and I can start to share things back and forth. Disadvantages of this, though, is that there's no centralized administration. Every single computer would be in charge of sharing things out and setting the permissions on it. Every single computer would be in charge of doing their own backups. It's not quite as scalable. In Windows networking, a peer-to-peer network is typically known as a workgroup, whereas a client-server model in a Windows network would typically be known as a domain. Categories of components that make up a network that Cisco talks about in this chapter. One is your devices, the next is your media, and the last is your services. First, we'll talk about devices. They divide our devices into a couple different categories. We have end devices, and this is what you're probably most used to using because you as the end user get to interface with this. This is your computer, such as a laptop or a workstation, network printers, voice over IP phones, security cameras, mobile handheld devices, anything that you would use to access the network or the internet or some type of service. This would be your end device. An intermediary device is a network infrastructure device. Intermediary devices help us with our connection to the network. They get our packets onto the network, routed on the network, and they can protect us from security threats on the network. Some of these things are our switches, our wireless access points, our routers, and our firewalls. We talked about our network media. Our media is what our data travels over. Most often it's probably going to be copper type of cable, like Cat5 or Cat6 cable. The reason why copper is probably the most popular is it's cheap and easy to use. If you are in class, within a matter of 5 minutes I can show you guys how to make a copper crossover or straight through cable. Pretty simple. Fiber optic uses light pulses to send our signals. Fiber optic can typically go longer distances, can go faster speeds, but it's a little bit harder to work with, requires a little bit more skill, a little bit more specialized tools to be able to splice and put the ends on fiber optic cable. But bottom line is it's still more expensive than copper media, and that's probably why we don't see it out there quite as much except for our backbone and server runs. We also have wireless. Wireless is becoming probably the most popular choice lately. With wireless, we use radio waves and we send our signals through the air. The nice thing about wireless is we don't have to run cables through walls, especially in existing infrastructure or an existing building. We don't have to be poking holes in walls and ceilings and things like that. We can just set up our wireless connections. All different types of media are going to be categorized by how fast and how far the signals can travel. This slide is a great reference to come back to for how things are going to be represented in topology maps as you move throughout the Cisco curriculum. Our end devices, again, like our computers and laptops, these are some of the different symbols that we'll see. We'll see all these different symbols in the packet tracer. Intermediary devices, routers are always going to be circles with the antenna as a wireless router. Switch always has multiple lines. If it only has one line or arrow, I should say, it would just be a hub. This is a multi-layer switch, which you'll learn more about in the third semester of Cisco. This is a firewall. How we represent our media is typically going to be straight or dashed lines. And the blue is always going to be our wireless media. Different types of networks that you'll hear about are LANs, WANs, MANs, WLANs, and SANs. A local area network is going to be confined to a local geographic area. One home, one building, one campus, all under one administrative control. LANs typically operate at faster speeds than, say, a WAN does. A WAN is a wide area network. This is typically two LANs separated by a larger geographic area. Take the North Dakota University system as an example of a WAN. We have Bismarck State College campus connected to NDSU's campus, connected to UND's campus. While Bismarck and Fargo are 200 miles apart, we're using some type of WAN connection, like maybe a T1 line or fiber optic, to connect those two LANs together. Our WAN speeds in between the two LANs are typically slower. The Internet. The Internet is really just a series of LANs and WANs that are all connected together. At the core of the Internet, we have our Internet service providers like Qwest or Verizon or Midcontinent, and they're all connected together. The individual LANs then connect to the Internet service providers. All these different connections form an internetwork known as the Internet. There is not one particular entity or person that owns the Internet. It's, as I said before, just a series of LANs and WANs all connected so that we can all have access to the different resources that we are putting out there. Here's a few more related terms that you might hear about. Intranet. Intranet is local to your company only. Typically, only company employees can access your local intranet. Extranet. Extranet extends to trusted suppliers, customers, or collaborators. Maybe you allow a supplier to access your inventory database, or maybe you allow a collaborator to access a document that you're working on together. And then, as we said before, we have the Internet, which is available to the whole entire world. How do we access the Internet? What type of technologies are available? Some common types of technologies to access the Internet are DSL, cable, cellular, satellite, and dial-up telephone. And they all vary in terms of speed and availability. Cable on that list is probably the quickest, where dial-up telephone is the slowest. It used to be that networks only provided one service. Cable television, for example, only allowed you to watch TV. Cell phone service only allowed you to place calls. Well, as things evolved, our networks started to converge together, meaning that instead of having separate networks for each individual service, they all run on one converged network. Think of your cable TV service provider now. It provides many different things for you. You can watch TV, you can do video on demand, you can get your landline telephone service through them. Think about like Verizon. What can you do with Verizon now? You can send text messages, you can call, you can stream video. Many different things that you can do on those different networks instead of just calling or just watching TV. We have converged services. As we go into the future of networking, we need to take into account all the different devices and things that are going to be connected. As this slide says, the human network is everywhere, and people want to have things with them on the go. So being able to scale our networks and be able to support our networks and host all of these different things is going to be vitally important. So as our networks evolve, we want to follow these 4 basic characteristics with our underlying architecture to make sure that we can meet the user expectations. We have fault tolerance, scalability, quality of service, and security. Fault tolerance is the ability to recover from a catastrophic failure. If something goes down, how long are we going to be without service? If you take a look at this example here, we have 2 telephones that are going to be communicating with each other. If one of these telephone switches happens to go down, we could still route the traffic to another switch and get to where we want. So this has multiple fault tolerance built in here. We can take redundant paths to get to where we want to go. Fault tolerance is great on a network, but it does increase the cost of the network, and it does provide a little bit of administrative overhead to set this all up. Scalable networks. Scalable networks mean that we have the ability to add or expand upon the network, and the key thing is not decrease the performance of the current users. Can I add 50 or 100 users to my current wireless network without affecting the other users? If you can say yes to that, that means you have a scalable network. If you're going to add users to your network and the performance is going to start to degrade, then you do not have a very scalable network. So keep scalability in mind when purchasing equipment and setting up network infrastructure. Providing quality of service. Not all data is created equal. What I mean by that is if I'm going to surf the internet, if I pull up Google's webpage is going to look the same no matter if it took 2 seconds or 2 minutes for that page to load. Nothing is really going to change there. But if I'm going to be sending video data across a network, it does matter if it takes 2 seconds or 2 minutes because I'm going to have buffering and choppiness. If I'm sending voice data over a network, I want that to come through as quick as possible because, again, I can really affect the quality of that call. So when setting up equipment and planning networks, you want to provide some type of quality of service. Have your important communication come through the network quicker. Give it higher priority. Things like telephone or video or vital transactions. Things that aren't quite as important, that aren't really going to change, no matter if it takes 2 seconds or 2 minutes to come through, like web traffic or email. That's really not time sensitive. You can decrease the priority of that. And we have network security. Some things that we can do with network security are implement a firewall, have some sort of access policy. We can encrypt our data. And what we're trying to do is we're trying to stay one step ahead of the cyber criminals out there so that they cannot steal our data, intercept what we're trying to transmit, and we can keep things on our inside of our network safe. Some of the top trends in networking include bring your own device. This is kind of a buzzword here over the last couple of years, or BYOD. Online collaboration, video, and cloud computing. Bring your own device means that users are going to start bringing in their own devices into the workplace. A lot of times when you go into a workplace, you have a business-issued laptop or business-issued desktop. With all these different devices out there like iPhones and iPads and other sorts of tablets and PDAs that are out there, users want to bring in their own devices, and this can cause strain on the network. You don't have complete control over someone else's device that they own. You may not know the security behind it. So this is becoming more and more of a problem, or more and more something that network administrators need to be aware of. So bring your own device again means that users are going to start bringing in their own devices to connect to corporate and company networks. Online collaboration is huge, allowing users to communicate and collaborate that are miles apart. No longer do we have to hold a meeting where everyone has to come into the boardroom. We can have people teleconference in or video conference in. Things like instant messaging instead of having to pick up the phone and call people. These are becoming more and more important with online collaboration. For example, here this slide shows how many people are on the internet. Year 2012, there's 2.08 billion worldwide internet users, and of the traffic that they utilize, 40% of it is video traffic. Internet video will become 62% of all consumer internet traffic by the year 2016. So we have a lot of different video and video counts and streaming that happens on the internet, and as we know, that can use up a lot of bandwidth, and that does comprise a lot of the internet traffic that's out there. Cloud computing. We hear a lot about cloud computing, and what cloud computing means is that we're using some type of service that's not hosted on our local area network. We're connecting to the internet, and we're connecting to a service provider to perform a function for us. An easy example of that I can think of is cloud-based storage. Instead of storing documents and pictures on your local computer, for example, in the My Documents on the hard drive, you would be storing it on a cloud-based service like Dropbox. Submit it to the Dropbox, it goes out to the internet, out to the service provider, and onto one of their servers that they host. Again, it's not on our local area network, it's out on the cloud per se. There are different types of clouds that are out there: public clouds, private clouds, custom clouds, and hybrid clouds. I'm not going to discuss all four of those different types here in this video, but read through those in the curriculum. Mid to larger size businesses are going towards data centers. Data centers typically are going to house all of your infrastructure such as servers, storage, security devices. They typically have redundant communication connections. They're typically environmentally controlled with air conditioning, fire suppression, and also redundant power supplies. So when you hear the term data center, think of a facility that's used to house computer systems and all the associated components of that business. Technologies, trends that we may see in the home are smart home technology, being able to control your lights, your oven, everything in your house from your car, from your phone, from any smart device. Again, all going through the cloud or going through the internet. Using power lines for networking. This is a great idea because there is already an existing infrastructure for our power lines, and being able to send data over this can just further increase our capabilities for data communications in the home and also in the business place. With all of these different smart technologies that we have, we need to be aware of different security threats. The most common external security threats that there are include viruses, worms, and Trojan horses, spyware and adware, zero-day attacks or zero-hour attacks, hacker attacks, denial of service attacks, data interception and theft, and identity theft. Some of the ways in which we can try to thwart these attacks are using antivirus and anti-spyware. Keeping these up to date is vitally important. Using firewall filtering so that we can dictate which traffic is good and which traffic can enter our network, also which traffic can go out. Using access control lists, we can control access based upon a list. Using intrusion prevention systems to prevent intruders like hackers getting into our networks or detecting them. And also using things like virtual private networks to encrypt our data over public networks such as the internet so that it cannot be intercepted very easily. That is all for this video on Chapter 1. Some of the things that we discussed again were how networks and the internet have changed the way we do everything in our lives. We talked about how networks come in all different sizes, from very simple networks in our home, maybe 2 or 3 computers, to larger networks like the internet connecting millions of devices together. Because we rely on the network so much, we want our networks to be reliable as possible. We talked about things like quality of service and scalability and fault tolerance. Again, those are things that we want to keep in mind, as well as keeping our network secure as possible from outside attacks. And lastly, we talked about moving into the future. What are some different trends? Bringing your own device, using power line communications. Just some things to get us thinking about where networks will move to over the next 5 to 10 years. Thanks for watching.